This is Precalculus Openstax, session 3.6, number 15. Use the factor theorem to find all real zeros for the given polynomial function and one factor. Okay, so what we're going to do is we're going to try to write f of x equals some polynomial g of x times x plus 2. So what our suspicion is that this x plus 2 is a factor, or maybe they're telling us that, but I guess that's the whole idea, is that x plus 2 is a factor. So we want to find g of x. Now there's two different ways to do this. One way is, I'm going to divide x plus 2 into this polynomial. So when I say there's two different ways, I can use sort of the traditional long division of polynomials, or I can use synthetic division. So let me just do long division, although it's sort of takes a lot, it takes more time, and maybe it's more likely I'll make a mistake when I do that, but let's just see what happens with that. Okay, and the idea is I think it's going to go in evenly without a remainder. Okay, x times what makes 2x cubed? Well, 2x squared times x makes 2x cubed. So I multiply 2x cubed times x. Then 2x squared times x makes 2x cubed. 2x squared times 2 makes 4x. And then we subtract by adding the opposite. Little mistake here. It's 2x squared times x makes 2x cubed. 2x squared times 2 makes 4x squared. All right. So now when I add the opposite, this 2x cubed and negative 2x cubed makes 0. And then x squared plus negative 4x squared makes negative 3x squared. And then we can bring down, I'll just bring everything down. So then x times what makes negative 3x squared? Well, negative 3x. So negative 3x times x makes negative 3x squared. Now I multiply. And let's see if I can do it right this time. So this is the product. So negative 3x times 2 is negative 6x. Again, we add the opposite. And I get then x plus 2. And then x plus 2 goes one time into x plus 2. Multiply. And we get 0. So if the remainder is 0 when we do division, that means that this x plus 2, this divisor went in evenly to the polynomial. So the result is that 2x cubed plus x squared minus 5x plus 2 is equal to 2x squared minus 3x plus 1, all of that times x plus 2. Okay, so that's the result of this long division, plus a remainder of 0 divided by x plus 2. So we don't add 0 there. Okay, so now we know that one of the factors is x plus 2. So what does it mean when we're finding the zeros? What we're trying to do is we're trying to take this guy, 2x cubed plus x squared minus 5x plus 2 and equal to 0. So we're trying to find the zeros. So then we factor it, 2x squared minus 3x plus 1 times x plus 2, and set that equal to 0. So that gives us 2x squared minus 3x plus 1 equals 0, and x plus 2 equals 0. Now x plus 2 equals 0 gives x equals negative 2. So that gives us one of the zeros. And now for this one over here, what we can try to do is factor this. But if that doesn't work, then we can use the quadratic formula. Why would I say it doesn't work? Well, not everything factors over rational numbers, over the integers. So even if we have, but this one I think does. If I'm looking at this and I think, well, I think I see something here. I see that, see, I don't really have a some plan to do this. But look, 2 is a prime number. There's not that many, there's only 2 and 1 as factors. So 2x times x makes 2x squared. Then 1 times 1 is 1, or negative 1 times negative 1 is 1. And you see that this factorization works because 2x times negative 1 is negative 2x, plus negative 1 times x is negative, add those together and get negative 3x. So therefore we're going to get 2x minus 1 equals 0, and x minus 1 equals 0. And solving here, 2x equals 1, x equals 1/2. Sort of getting to the very end, and I'm starting to get sort of messy, which I shouldn't do. X equals 1. So these are the 3 zeros of this polynomial, and there are no more zeros than that, because this we started off with a third-degree polynomial. Third-degree polynomial can have at most 3 zeros, real or complex. Okay, that's it.